Welcome back. I'm here to save the llamas again. Did I not say it right? No. Oh, okay. This is block 5 from topic 10. On page 329. We're gonna refresh our memory of a histogram we made a couple days ago. And what is a histogram? Is a fancy name for what?
Graphs.
What kind of graph?
Bar graph.
A bar graph. It's just a fancy name for a bar graph. So a couple days ago, we made a histogram of the student council and their usage of a track. And the numbers fell between intervals, right? Remember that? And we had to find the frequency of their intervals and then graph the histogram. Remember that question? Okay, so here's the graph of the student council's histogram that we made a couple days ago. Well, the tennis team did their own survey and they got all of this data, so they wanted to make a frequency table as well, using the same intervals. So they're gonna make their frequency table just like we made our student council one the other day. And we're seeing if the data ends up turning similar. Is it matching my histogram graph so far?
Yeah.
Yeah.
This is magical.
It is magical. Okay. So we found the first bar of our histogram. The first interval had 13. Did the tennis team get 13? Okay. The second interval we got 13. Did the tennis team get 13? Then we had, what is that, 11? Did they have 11? 4, 5, 3, 0, 1. So did the tennis team have basically the same data? Okay. We're gonna go with that. Does anybody really remember the exact numbers we worked with on the last problem? Do you feel like any of these numbers are different, or are they probably the same as the student council?
I think they're the same.
Maybe on similar.
Tristan said maybe they're just similar. I kind of remember our last one had a 3 in it though.
It did. It had 4 things.
Okay, what page are you on?
I'm on page 318.
Yeah, on page 318 had our table that we graphed of the histogram. Take a look at 318. Did the tennis team get the exact same numbers? No. I see on 318 there's a lot of 3s listed. Do I even have any 3s listed? No. But I got the same data, right? Of my histogram. How do I have different numbers of this, but my histogram turned out, or my frequency chart turned out the same?
They took out a couple ones, but added more T's.
Okay, but how is that making it the same? He said there's a couple more
They took out a couple.
They took out a couple.
Then added some more.
Added some more what?
2.
2s. Okay. How is that making my histogram the same?
It's still under the 1.7 to 3.4.
Okay, so he said it's still falling in the same category. So our other frequency had a lot of 3s listed, right? I don't have any 3s listed. I have a lot more 2s listed this time than I did on page 318, but doesn't the 2s and 3s fall in the same category? So that's how I have the same frequency table, but I had different data. Okay, we're going to be using that piece of knowledge here in a second, so keep that in mind. Okay, they're going to create a histogram out of their data. It should turn out looking the same since they had the same frequency. Looks pretty much the same to me, right? But that's because they had intervals.
I see a little bit of a difference. The 6
Tristan has a real keen eye in seeing a difference. I don't see any difference.
The second one on the middle 3, they look a little higher than the one on the left.
It is not, because it's the same data, just different numbers listed. Alright, let's take a look. We need to make a box and whisker of the tennis team's information. Okay, we already made a box and whisker for the student council's information. So now we're making one for the tennis team. Well, my numbers are kind of a lot nicer than your numbers. Why is my numbers a lot nicer? Because y'all's is not in order, right? Is mine in order already?
Yeah.
So y'all would have had to sit there and put them all in order first and then go. So we're gonna, how about we just use mine since they're already in order?
That sounds good.
Okay, and we have to find those 5 numbers that we need for our box and whisker. We had to find a min. What else did we have to find way down here? A max. What was in the middle? Median. Then what did I call those?
Q1, Q2.
Q1 and Q2. Those are the 5 numbers I have to find. Well, I've got to find my minimum. Well, what is my minimum? Number used. Huh? What is my smallest number? 0. What is my largest number? 12. Now I've got to find the median. So that means I need to cancel out in pairs until I reach the center. What do y'all think it's going to be?
A 3.
Or
It's gonna be a 3.
5.
Oh wait, no, it's gonna be a
That's
2.
just randomly guessed.
It'll be a 2.
We already crossed out one. No,
It'll be a 2. It's a 2.
that's a definite 2.
That's a big 2
It'll
right
be a
there.
definite 2.
Definite.
Called it.
Both of those 2's end up in the middle. Well, are they the same number?
Yeah.
So what is my median?
2.
Definite
A 2.
Definite 2.
Yep. Then quartile 1 and quartile 2. That's my median in the lower half. Here's where it splits, my middle. I've got to find my median now of my lower half. So now I've got to do this for the lower half. What do y'all think it's going to be?
Something.
Well, I hope it turns out to be.
It's gonna be a 0.
Um,
It's a 1.
definite.
Oh, definite 1. So 1 is my lower quartile. What y'all think of the upper?
6.
Mid.
6.
Yeah.
6. Told you.
Yeah.
6.
Knew it. Definitely 6.
Okay.
No, I
We
said-
found those 5 numbers. Now I need to put it in my chart that they have. First thing they ask is the lowest value in the data. What do I call that?
Min.
The min. So what is my min that I found? 0. Let's plug that in.
Whenever you do quartile 2, I already knew it was 6 because I just thought of like 2 times 6 equals 12.
You can't do it like that.
Just to,
It's not going to work every time.
I know.
Okay, the greatest value in the data. What do I call that?
Max.
Max.
No, the greatest. The largest number, what do I call that? The max. What is our max? 12. Median of the data, what do I call it? The median. What did we find the median to be? 2. Was it 2? I don't remember.
Yeah.
Okay. Lower quartile, what do I call it? Q1. So what did I find? I don't remember what I found. 1. 1. And then our upper quartile is 6. And I submit an answer here, and thank goodness we're correct. Now that I have these 5 numbers, can I make my box and whisker?
Yeah.
Yes, I can. So that's what we're doing on number 2, making our box and whisker. It's kind of cool. I have little sliders. So where does my min need to start? 0. So I'm going to drag that to 0. What about my max?
12.
Goes to 12. What about my lower quartile? Where is that? 1. Our median is at 2. And our upper quartile is at 6.
This is the exact same one that we did the other day.
It's similar.
Yeah.
Okay, so you need to have your box and whisker drawn out.
I do.
Alright, so we drew the box and whisker for the tennis team now. So on number 3, do I have people still drawing box and whisker? Number 3, we're going to compare the student council's box and whisker and the tennis team's box and whisker we just created. Are they identical?
No.
What? Raise your hand. What is different about these 2 box and whiskers? Presley? Is it called the lower? Is the lower different? No. The lower quartile is not different. They're both on 1. What do I call that? Huh? Let's go. What is this? What do I call this? My min or my lowest. Are they the same or different? Same. Here's my lower quartile or Q1. Are they the same or different? Same. What do I call this middle line? Median. Are they same or different?
Different.
Oh, they're different. Is my upper quartile same or different? Is my max same or different? So they have very little differences. So on A, they ask, are they the same results? We're going to say no. The medians are different. One median is at what value? 3. And the other one is at 2. So we talked about B a little bit earlier. B says, why are the histograms from the 2 surveys the same, but their box and whiskers are different? So our histograms turned out identical, But our box and whiskers turned out a little different. What did we say earlier of why they ended up being the same histogram?
I have the same amount.
Isaac?
Because, the student council has 3, but, the tennis team doesn't have the 3.
Okay, the student council had a bunch of the 3s listed. Did our tennis team have any 3s listed?
No.
No. So they had different data. What caused the histogram to be the same? They fell into, you said the same, when I did my frequency chart, they fell into the same intervals. So the same intervals, isn't 2 and 3 falling between that 1.7 and 3.2 interval? Yes. That's why they all read the same. So the histogram combined values into intervals. The box and whisker gave more specific numbers. The histogram was not very specific because their information was in intervals. Okay, and we have one last question on C. We have people still writing? Can I flip? Okay, one last question, C. Says which survey seems to show more hours of use by students? The student council or tennis? More use by students. Why do you say the student council?
The median is different.
What is different about the median? Why'd you choose
The number.
Because they have more hours.
Because the median of the student council is higher, so the student council survey says that it shows more hours of use. This one's showing fewer hours because it's not a whole lot fewer, but just a little bit. So the student council had a median of 3 hours versus the tennis team had a median of 2 hours. And that is it. We're going to spend the rest of the hour working on online work. Thanks for listening. Like, subscribe, hit the notification bell, and
Cheers.
peace out, llamas.
Cheers.
Hey!